Okay, 8th graders, so here is scientific notation. Scientific notation is a way that we are able to write very large numbers and also very small numbers in a shorter, concise way. Okay, so first I'm going to show you how to write a very large number in scientific notation. So scientific notation, so for example, if we use the number, 38 million. Okay, 38 million. So 38 million, the first thing we have to do when we do scientific notation is we have to find a place to put the decimal point in which the number in front of the decimal point, meaning to the left of the decimal point, is between 1 and 10. So we can always do it this way, the long way, and we just start by covering up zeros or covering up the digits until we get to a number. So here, if we covered that up, what's left over would not be between 1 and 10. Also here, also here, also here, also here, also here. We have 38. Up, here we go. So we would have 3. So we know that the decimal point must go between the 3 and the 8. So we're going to write the numbers, except for the end zeros, where that decimal point went. So we're going to put 3.8. Okay, we drop off all the end zeros. And then we put a times 10 because with scientific notation we always put a times 10. And then what we are going to do is we're going to start here at the end and we're going to count how many places it took for us to get to the decimal point over to the 3.8. It's just simple counting. We go 1, 2, 3, 4, 5, 6, 7. 7 places got us to between the 3 and 8, and that becomes the exponent on our scientific notation. Okay, so I'll show you another example of that. So if we did, let's just say 20,800. This is a little bit smaller one. 20,800. Okay, so what we're going to do here is we're going to move the decimal point. We're going to start with the decimal point at the end. We're going to move it so that the number to the left of it is between 1 and 10. So we move it here. It's not between 1 and 10. Move it here. That number is 208, not between 1 and 10. Move it here. That number is 20, not between 1 and 10. Here, the number is 2. Bingo, there we've got it. So we're going to put 2 point. We need to keep the 0 and the 8 because all we take off is the end zeros. But the 0, because it's in between two other numbers, we're going to keep it in there. Okay, we're going to put times 10, and we're going to count how many places we moved. So we moved 1, 2, 3, 4 places. I think that's right. 1, 2, 3, 4. And that becomes our exponent. So that's how you write a number, a large number in scientific notation. Now, just the converse of this, because the other way is to write it in standard form. So if we had something like 3.2 times 10 to the 5th power, and we had to write this in standard form from scientific notation, what we're going to do is put 3.2, and we're going to move the decimal point to the right, the amount of places that is in the exponent. So in this case, it's 5. So we're going to move it 1, 2, 3, 4, 5 little jumps to the right. And any holes, any gaps, we need to fill in with zeros. And then if we want, you can copy the number over again so it looks nice and neat without the jumps, and put in your comment every 3 starting at the right. Okay, so let me show you one more example of that. So if we had 5.04 times 10 to the 9th power, something like this. What we're going to do is we're going to write our 5.04, and we're going to count 9 places to the right. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Put the big decimal point. That's fine if it looks crazy, a little sloppy. I'm going to put in zeros here in all of these little hops, and then we can recopy the number 1, 2, 3, 4, 5, 6, 7. Okay, and then we can put in our commas. There you go. So that's how we do scientific notation, both taking it from a standard form to scientific notation and scientific notation to standard form.